So graphing lesson 2, part 1. So let's first look at the difference between what a linear equation is versus a nonlinear. So the official definition is the linear equation in two variables, equations that can be written in this form of ax plus by equals c. A, b, and c are real numbers. And those are just constants. Here's some examples of linear equations. 4x plus 2y equals 9. 2x minus 3y equals 11. Y equals 4x minus 6. Why is this? Because I can rewrite this in that form, right? I can subtract 4x from both sides and get negative 4x plus y equals negative 6. 1/3 x minus 5/3 y equals 11. Nothing wrong with them being fractions. 4.12x plus 2.08 equals 3.18y. Again, we can subtract 3.18 from both sides, subtract 2.8 from both sides, and just switch those two around. And finally, y equals x. We could have negative x plus y equals 0, right? So we can write all of these equations in that form. So let's look at some examples of nonlinear equations. And something else that should be said about the linear equations is when we graph these, every one of them are going to be nice straight lines. So 3x squared minus 2y equals 1, an example of a nonlinear equation. xy equals 8. So look at this 2 here. The squared on the x, there's no way to get rid of that without creating some other stuff that would also be hard to get rid of, so like square roots. So I cannot write that in the form of ax plus by equals c because that's squared. Similar with the x and y, I can't separate those. Those are being multiplied. So graphically, what do these things look like? Okay, let's look at this over here. So the graph here is going to be something that's nonlinear. It's not a straight line. We call this one a parabola. Again, xy equals 8, nonlinear. Another one, y equals 2x minus 1 over 3x plus 2. You may think you can multiply both sides by 3x plus 2. No, that's not what you're thinking. Well, we can do that to at least remove that, but then we have, again, a product. So whenever we have products of x's and y's that we're unable to sort of split apart, that aren't going to cancel out in some way, it's going to be nonlinear. Similar here, 3x to the negative 1, this negative exponent. If you recall negative exponents, this is basically the same thing as, or is the same thing as 3 divided by x. It reciprocates the base, whatever it's being raised to. So graphically, this is what we get. Very similar when we multiply x's and y's. Again, notice the similarity between these two graphs. So when I divide by x's, this is what happens. A couple more. 3x to the 1/2 plus y equals 7. 4 over x plus 3 equals y. So graphically, again, these are not going to be straight lines. Again, notice when dividing by x's, the traditional graph we get. Okay, so pause the video here. This is the type of question you could be asked. Which equations below are linear? You ought to be able to see an equation and quickly recognize if it's linear or not. All right, welcome back. So this first equation is definitely linear, right? We can write this in the form of ax plus by equals c. Part B. Yes, it's also linear. Maybe the fractions threw you off, but we can have fractions for these numbers. Okay, it's when fractions end up being in the exponent of the x's and y's that messes us up. This one's nonlinear, right? We have an exponent of 2 on the x. So let's use the grapher to graph the following equations, and let's just explore the linearity from these. Like if you're looking at these and you're like, I still don't know if it's linear or not, you can always graph them. I say always. Sometimes it's really hard to tease out the x and the y, to solve for y explicitly. So you want to be, if you are not able to do that, it is not going to be linear. If you're not able to solve for y, or if y is not able to be solved for, I should say, it's not going to be linear. So I'll do this first one step by step, and then I'll let you do the other 3 on your own. So y equals 4x minus 3. I think you have a sense that that one is going to be linear, but let's see what it looks like. So step 1, press the y equals on the calculator, and then clear anything out that's in there. If you see any of these plot 1s or plot 2s highlighted, go ahead and just scroll up there and press enter and make sure they're all unselected. Type in the equation 4x minus 3. So now we have y1 equals 4x minus 3, just like we have up here. Let's start by graphing this on the standard viewing window. So just press zoom and then select 6. And we get a nice linear graph. Go ahead and work on the other 3 on your own. So pause the video here, see if you can graph those and get them to come out. Okay, welcome back. So hopefully these came out well for you. This first one, the second one, B, graph it. You get a nice linear graphic. And again, we look at this and we say, oh, we can write that in that form. I can add 2x to both sides and get it as 2x plus y equals 1. You don't have to do that. Soon enough, we'll learn that this is in a different form of y equals mx plus b. How about part C? Y equals x squared plus 3x plus 1. We get a nonlinear graph, right? So this would be nonlinear. And B would be linear, C would be nonlinear. This is a parabola. And finally, D, we're dividing by x. We are not going to have a linear graph. So this again is a nonlinear graph. I want to graph a few of these live for you. This is desmos.com, free graphing utility. So let's graph this first one, 3x squared minus 2y equals 1. I just type in 3x. To use an exponent, I press shift 6 with a little caret key. Minus 2y plus 1, and then press enter. Sorry, equals 1. And there's our parabola. Okay. This next one was xy equals 8. And there we go. So let me exit out this one. So let's graph y equals be 2x minus 1 and divided by 3x plus 2. And again, nonlinear. Let's do one more. Be 3x to the negative 1 minus 3y equals 5. It's that black one there. Let me move this one here. There we go. Again, non-linear.